All right, so, we ready to start yet?
Yeah.
I don't know.
Honestly,
I need a vacation.
You just wanna take a break this first period?
Yeah, we can just have a
Good.
second.
Thanksgiving break.
All right, so, first family is hydrogen. Hydrogen is a family in its own. All right, it was called inflammable air by Cavendish. It was called water former by Lavoisier. These are two scientists that had dealt with hydrogen when it was first discovered. Called inflammable air because it's not combustible unless it combines with oxygen. When it combines with oxygen, then now it's flammable. All right, when it does combine with oxygen and it does explode, then water is formed, so that's why Lavoisier called it water former. And again, some of these scientists, a lot of times these scientists, when they make these discoveries, a lot of times these discoveries were found by accident. Just by them doing stuff in the lab and something happens, and oh, here it is. Not sure exactly all what Cavendish did or what Lavoisier did, but they did name hydrogen these two names. Some of the physical properties, you know, hydrogen is colorless, you can't see it, you can't taste it, and you can't smell it. Hydrogen stays in the gas state. Now we have been able to get liquid hydrogen, but what we have to do, we have to lower the temperature a great deal, and we have to increase the pressure a great deal to be able to push those gas molecules close enough together so that we can combine them to make it a liquid. We can't get solid hydrogen, not possible, but we can get liquid hydrogen, and we use liquid hydrogen a lot of times in the space program when they're using it for a type of fuel, and they'll store it as a liquid, which makes it a little bit more stable and a little bit more easier. Some of the chemical properties. Why is it a family by itself? Well, it's over here in the metal side, but it's not a metal. But it's over here because it has one valence electron, which is all these elements do. But it could be over there in group 7A, because it acts like a halogen as well. Because how many valence electrons does it need to become stable? Well, it has one energy level. How many electrons can one energy level hold? Two. So it has one, so all it needs is one more. Same thing with all the halogens there. They have 7, they need 8. They only need one more. So it's very similar to those as well. So that's why they have it on the top of the periodic table. Everybody hear me all right? Sounds like I'm muffled.
No, you're good.
I'm good? You sure? No?
No,
All right. But that's why I slide it over there, because it could act like that type of element too. It can gain an electron to become stable. It can lose an electron to become stable, or it can share an electron to become stable. It is the only element that does all three: gain, lose, or share. All the other elements do not do all three. So they're able to give or receive an electron. When combined with a metal, it forms what is called a hydride. So if it combines with sodium, it's sodium hydride. When it combines with a non-metal, it forms an acid. So that's not on there, but the metal is. Put the non-metal as well. When it combines with a non-metal, it forms an acid. When it combines with a metal, it's called a hydride. So hydrogen is a very versatile element. It can do a number of things depending on what it combines with, or what it comes next to, or what it is the presence of. So that's why it's basically a family on its own. It can be a 1A element, or it can be a 7A element. It can lose an electron, it can gain an electron. And it's the only element that can do that. to become stable. So that is hydrogen. Any questions on hydrogen? And again, we're going to fly through these elements, and as you read, there's a lot of information there. I'm not expecting you to remember all the information. I'm expecting you to remember some of the key informations. But the names are important. Inflammable air, water former, they're important. The next group, alkali metals. The group 1A elements. A man named Sir Humphrey Davy first isolated an alkali metal. These metals are very reactive because they only have one valence electron. And they lose them very easily. The ionization energy, the electron affinity over here on the left side of the table, we learned the last couple of days, is very low. So it will not attract an electron. It does not hold on to its electron very easily. So it loses it very easily. So they're very reactive, never exist by themselves in nature. I have some samples of these. Let me show you those. They are soft metals. They're easily cut with a knife. And those of you in physical science class, you've seen this before with these. See if I can get these out. Well, they react very easily with water. They're low dense. They're not very dense. They'll float in water. They easily cut with a knife. I don't have my razor blade, so I'm going to use my scissors. One valence electron reacts violently to water, so that's why they're stored in mineral oil.
Have you ever flushed one down the toilet?
I have not flushed one down the toilet. I don't carry these around at home very much, so
School toilet or
You think
well?
that,
It got air in it.
you think the toilet would blow up?
it depends on how big of a piece you put down there.
Huh? Let's do it,
Yeah, that's good.
Either way, you're gonna need a snake. Check.
All right, so this is lithium. All right,
What's it? No.
looks very
Looks like clay.
yeah, but
Looks like a metal.
it is a solid, but you can cut it with a knife, which we'll show.
Can you bend it?
Can I bend it? I can't really bend it. It's not bendable, but it is cuttable,
Is it brittle?
not brittle.
What?
Oops.
That's weird.
Gotta go handle it here in a
Oh,
second. So it cuts
this
a
is
little too.
All right, so you can see.
Luster.
All right, it's like a metal. It has some luster. But most metals you can't cut with a pair of scissors. At least a thick piece like this.
You need
They should
shoes.
make jail cells.
Yeah, so they can throw water on it and.
Can you put the
Blows
cup in the middle? Because I cannot.
You can't see it because Gary's big head.
Something
Yes.
is happening, guys. It's fizzling.
Is that better?
You dump all of it in there, Mr. Goldman?
Dump the whole chunk.
Dump the whole waffler smells.
Put it all in there.
Now, again, you can find some videos online where scientists are taking big chunks of these and throw them in a lake or something, and it actually has a big explosion, because it
That's
is
a geyser.
reactive to
Does it
water.
blow up like a geyser?
That's where I got the toilet idea.
Is that where you got the toilet idea?
YouTube.
It looks like a little like, what are they called? Sea monkey?
What?
Looks like a sea monkey running on the edge.
All right, this is sodium. All right, let me bring it over here so the people in the video can see.
Let's
This
throw
is
it.
sodium here.
Let's throw all three of them in there at
Okay.
the same time. That looks like sticky cat.
It's salt.
Now, sodium's a little bit further down, so what is it? The ionization energy as we go down does what?
Increases.
What's that?
Increases.
Does what?
Decreases.
Decreases.
There you go, boy. That's what I said for the first
So
time.
we did it the first time, I didn't hear you the first time?
Yep,
Does
definitely.
the
I
mass-
definitely said that the first time.
Yeah.
You wanna taste it?
You wanna taste it?
Does it taste like salt? No, it does not taste like salt.
Well, I mean, it is also covered in like a weird liquid, so.
All right, again,
Just curious.
there's the luster that you see.
Now
Where's
he's
the
gonna
small
fill that
piece?
hole. Now he's
Now
gonna
it gets
fill that
more
hole.
active because the ionization energy is less. So I don't know if you can,
Or more active.
it gets more active.
Throw the hole
So it
in.
should react more violently to water. Now again, I don't wanna throw all that in because I don't want glass flying everywhere in water.
It's okay.
That would be the best part.
We've got a couple bars in there. We're good now.
And if I get a lot of parents happy with me about that.
You think my mom would care? No. Oh, that one had fire. Oh,
It's like going,
look at that
just
sea
zooming
monkey
around.
go. It's a sea monkey.
Yeah. Where do you buy this stuff?
Where? It goes in a triangle.
Should move this so they can see.
Guess how it goes in a triangle? Money really see that.
Where do we buy it? Well, no, it doesn't.
I guess it would be a massive explosion.
Dad, where do you
that
buy
one
this
costs
stuff?
fire. Can you do a bigger chunk?
No.
Wait, this one already pushed the limits here.
Yeah, I was gonna say, I respond.
I'm more responsible than a lot of us are, so
Well, you're also like
Where?
50 and we're teenage boys.
that is true.
Lame.
So where can we buy this?
Chemical supply store, you have to be part of a school.
You being for real?
Yeah.
Can you get me a bottle?
My mom. Your mom.
I'll pay
She's
you.
part of a school.
Oh, I guess.
She's a teacher. Yo, hit me up.
Alright, this is potassium.
Go to woman's house.
This is potassium.
It's even further down.
Throw a blueberry.
We should throw some francium in there.
Well, francium is radioactive, so that probably would not be a good thing to get.
Nice.
Let's still do it.
Why? Does that sound off like a bomb threat to the government, I wonder? If you buy a large sum of francium? If you buy...
From France.
Francium is very unstable, so you don't see it too often.
Except in
I
Mitchell's
thought
office.
sometimes
We can massive chunk and get it back up.
I know, I saw that. I saw him picking up. I was like, whoa, there.
Dad, I don't want the massive.
Whoa.
Oh.
That one's way cooler. I like that one way more. Again. Again, use the other chunk.
So that's just a small piece.
Oh.
Oh.
Can you imagine what a big piece is?
Oh,
it's on your
Glasses? What's the cut?
It burnt my book.
More. Again. Put all three of them in there at the same time.
Put
Yeah,
water
right.
on the book and drop it on top.
Alright,
Now
so,
look like there's just backwash in it.
so can you imagine if you put a big chunk in there? What would
No,
happen?
Can you do it real life?
So
I feel like
it's
never
Can't
thought-
imagine it. No imagination.
Bishop Bowman.
very reactive to water.
What
What's
if it
that?
like- What if it was like your first year teaching and you didn't know? And you just put a big old chunk.
But it's not my first year teaching, and I do know.
What happened your first year
Yeah, I was
teaching when
gonna
you
say,
did it? What happened your first time doing it?
No, I always knew to put a little bit.
Okay.
Next time,
You know,
it
when
rains
if I
really
ever
hard,
become a
let's
chemistry teacher, I'm
do,
gonna do
Let's
it.
throw it outside.
Big chunk in there.
do a big chunk in Lake
Because I've
Norris.
seen the video.
Yes. When Lake
Oh,
Norris,
I've
when
seen
Lake
the video.
Norris fills up, let's see how.
Lake Norris fills
Let's
up.
see what kind of
Yes,
crater we can put in there.
but
The reservoir down there. I call it Lake Norris.
Why is
Yeah,
that?
yeah.
Well, I forget who started calling it that. But
He did.
No,
Or some.
he didn't call it that. I think it was Larry
Is that
Sisson
where
who
we
started
play
calling it
football?
that. What?
The way
Yeah.
we play football or
alright, that's the group 1A metals. Group 1A elements.
The passive.
The alkali metals.
They call it Lake Norris.
The alkali metals. One valence electron is his common characteristic in that family. The group 1A. Conduct electricity well. Have a bright luster when freshly cut. Low density, easily cut with a knife. One valence electron, most reactive family. Because it only has one valence electron, so it loses electron very easily. Lithium properties resemble that of magnesium. Alright, so here, and again, what's the ionization energy that go from left to right?
It gets bigger.
It gets bigger, so the elements get less reactive as it goes left to right. So lithium, they say lithium, as you notice when we put it in the water, was not that as reactive. It took a while for it to start because it had to get all the corrosion off it before it started reacting with the water. The corrosion helps protect it. So it's very similar like to magnesium. Magnesium is reactive, and we'll talk about this, if it's put into some hot steam. Alright, hot steam.
What about the steam makes it reactive?
Because steam is a lot hotter than water. Alright, so we need to have that extra energy to be able to steal. Because what is ionization energy? Energy necessary to remove an electron from an atom. So just hot water is not enough energy to remove that electron, but hot steam is enough energy to be able to remove that electron. So therefore, it's able to react that way.
Weird. I wonder how people figure this out. I wonder if the first guy who ever put stuff in the water just
Like it
big
just-
chunk.
Catches on fire.
All right, group 2A.
Hold it around, put it on the edge.
Group 2A.
Oh, this hair scissors on.
Alkaline earth metals. The alkaline earth metals. All right, you hear this a lot of times. You hear it with batteries, alkaline batteries, or the alkyl group, alkaline. This is part of the elements in this category. We have beryllium, magnesium, calcium, strontium, barium, and radium.
I found this book.
All right? Alkaline earth metal has a shiny luster under its coating. Again, the coating helps protect it. Not as reactive as the alkali metals, but they're harder. They don't float like these metals do, so they're a little bit more dense. They're found in its rock structures, but not in its elemental form. You're always going to find these combined with something else, most likely. Now, if you watch some of the movies, some of these, take for instance, I think National Treasure had that where they had a magnesium vein going through some rock and they were able to get it caught on fire to start a fuse. Some of these movies that have that. So you can find magnesium inside the Earth's crust, but magnesium is very flammable. If you start it burning, it burns very brightly, right? And it's very bright burning. Sometimes they use it for a fuse for the magnesium. The chemical property has 2 valence electrons. The reactivity increases as we get larger, and that means going down the chart, we get more reactive. And again, magnesium, I said hot steam. Calcium would react to hot water. If I had a piece of calcium and put it in water, and you would start seeing bubbles, it wouldn't fizz and explode like the alkali metals would, but it does get, you can see fizz, it looks like it's fizzing like Alka-Seltzer or something. And again, Alka-Seltzer is a, what's the word I want to say? It's an antacid, right? Because a lot of it has calcium in it. Beryllium has a bridge relationship with the aluminum. All right. Again, you can see these elements here going down into the corner to the next family. Basically because those elements are really small, so they act like the element in the next family down below it, as far as their reactivity is. So if you don't necessarily have to remember the names, but just remember lithium and magnesium, they are cornered. Beryllium and aluminum, they are sort of cornered if we take this out. They are sort of corner to corner. So they have like a bridge relationship there where they have some similar properties there. All right, so that's the alkaline earth metals, group 2A. You got hydrogen, a family on its own. Alkali metals, group 1A. Alkaline earth metals, group 2A. Everybody done with that slide?
No.
Who said no?
Nobody's slower than Noah. What a guy.
Fast, you can learn them.
Dean and Ben and Alexander. Noah was the only one who decently kept up with him.
I did.
Actually, you burnt my book.
That's
You good?
Almost good.
Yeah, man.
It's only like 2 minutes long.
You should burn more than
I don't think we should continue.
Why don't we just enjoy our time together, let you get prepared for the next class, since you need the time.
No,
Because you seem to be on
he doesn't.
You seem out of sorts. Oh my gosh.
Transition metals, the group B elements. the Group E elements, those groups down here in the middle, these are our typical metals. Typical metals because these are the things that we most commonly think of metals. They're dense, they're hard, they're shiny, they sink, they are good conductors. So a lot of our metals that you know of, iron, lead, copper, nickel, zinc, silver, gold, platinum, a lot of these metals that we have heard of and we use, even nowadays, tungsten. Was watching the video the other day of these people making a Thor's hammer. And they had 3 different types of Thor's hammers. They made one of them out of tungsten, which is a very heavy metal. It's made it very hard. It's very dense, very heavy type of metal, which made Thor's hammer that they made very heavy, hard to lift. And people try to go in there and try to lift it, and they can't. So again, you get our typical metals. We have one metal there, that's a liquid, that's mercury. All the others are solids. They're malleable, they're ductile, they're good conductors, they're shiny. They have considerable strength, high density. They are our typical metals. What you normally think of as metals are these transition elements. Most of them have 1 to 2 valence electrons. Most of them have 2 valence electrons, usually from the S sublevel. Then we start filling the D sublevel from there. We have many different chemical properties. Some are non-corrosive, some are corrosive, some produce a magnetic field, some doesn't produce a magnetic field. I don't make you memorize those properties because there's so many different ones. That's just there, for example, that there's many chemical properties within this group, within this family. So we got hydrogen, we have alkali metals, we have alkaline earth metals, and then we have transition metals. Right, transition metals. We do the moles on Monday. Most likely your test will be changed to probably either Friday, most likely Friday of next week will be your test. We'll have a quiz on Tuesday of our families, and we'll go from there. Well, no, not Tuesday, probably Wednesday on our families. Thursday we'll review, and then we'll have your test.
Thank you, Mr. McLaughlin.
All right? Have a great day, guys.
Thanks, you too.